Okay, so here we go. We're going to talk about circles. The reason we save circles for the end is because circles are the one figure that we talk about in this class that are not a function. If you think about a circle, it fails the vertical line test, so it's not going to be a function, but it's still a useful tool for us, and it's pretty easy to grasp. So here we go. First thing I'm going to do for you is I'm going to define what a circle is. And so a circle is a set of points in a plane. That's important to note because if I change it to a set of points in space, then I'm defining, basically it's the definition of a sphere. Okay, so sphere is a very similar definition, just in a different realm. So it's a set of points in a plane that are all the same distance. Whoops, can't spell same. Parentheses called the radius. So it's a set of points in a plane that are all the same distance, and that distance is called the radius from a fixed point called the center. And in our nomenclature in this class, our book uses the letters H, K to denote the coordinates of the center of a circle. So I'm just going to put that right there. Give you a moment to write that down. So in case you can't read my writing, I'm just going to say it out loud again. A circle is a set of points in a plane that are all the same distance. That distance is called the radius from a fixed point called the center. Now that's fun, good times there, but that doesn't do a whole lot for me. So what we're going to do is we're going to come up with the equation of a circle called the center radius form. And if you remember, mathematicians are not creative in their labeling of things, they're descriptive. So you can guess that this equation we come up with is going to tell us the center and the radius of the circle, and you'd be 100% right. So where we're going to start this is kind of where we began our semester with the distance formula. You could say we've come full circle. That just occurred to me. I know no math jokes, but I'm amused with myself right now, so sorry. I know, I'm feeling all feisty because it's the end of the semester. All right, so we're going to start with the distance formula. So if you remember, and it's good to remember the distance formula because there's a distance formula problem on the final exam. Okay, so this is good. Put a little asterisk by this. So I'm just going to recall, or help me recall. Does anyone remember, I know it's 14 weeks ago, what the distance formula is? I heard somebody say there's a square root, or maybe I'm imagining things, but I'm going to give you credit. There's a square root there. All right, I understand. It's been a long time, so don't beat yourself up over that, but you do want to review this, I promise. So x2 minus, whoops, that's a minus x1 squared plus y2 minus y1 squared. Remember when you all were looking at me and you still liked me back on the first day of class, and we talked about the Pythagorean theorem, and then from the Pythagorean theorem we came up with the distance formula. That was our first day. You still had warm feelings. Now you just can't wait to get out of class. I totally understand. Okay, so now what we're going to do is we're going to substitute in the appropriate things from this definition of the circle that we just saw. And so from the definition, we know that the distance that we're concerned about, the distance from the center of the circle to the outside, is called the radius. So instead of a d there, I'm going to put r for the radius. Underneath the square root, we want all of the points on the circle, all of those xy values, they're going to be that distance r. So here's what we're going to do. Like I mentioned, our book uses h and k for the center. So I'm going to use that, all the coordinates on the outside of the circle, all the x's and y's. Let me actually, because I just keep saying this, let's pretend this is our circle right here. And right here, this is my center. This is h and k. And then out here, this is just some point on the circle, x, y. And this is my radius r. So I want my equation that I'm developing here to represent that quick sketch that's pretty messy. And you've probably concerned that you paid more money than that sketch is worth for this class. Okay, so here we go. So my distance between the x's is going to be the x variable that's on the outside of the circle minus the x value of the center, which is h. And then my distance between my y's is the y value that's on the circle minus k, which is the y value of the center squared. And then we're just going to do one more thing, and then you've got for yourself the equation of any circle. And what we're going to do is we're going to get rid of that radical. And so in order to get rid of the radical, I am going to square both sides of this. Okay, that should seem familiar. We spent a couple sections talking about that. And so what I end up with, and what I'm going to write down now, this is the center radius form of a circle. And it is this: r squared is equal to x minus h squared plus y minus k squared. So this is the equation that I want. That's the center radius form of a circle. So our first couple problems that we have here are just going to be to familiarize ourselves with the center radius form of the circle. So I'm going to leave it right there at the very top of the screen. And we have just enough screen for our problems that we're going to do. So here we go. First problem, example 1. I'm going to do this with you. It says, find the equation of a circle with a radius of 6, a center of -3, 4. So I've given you all of the information to plug and chug. And then we're going to draw a graph of this circle, and then also give the domain and range. So it seems like the never-ending problem. So here goes. I'm going to start, if you don't mind, I'm just going to reverse the sides. I'm going to start with the x minus h squared, y minus k. I'm going to put the radius squared on the other side. You don't have to do that, but it's what I'm going to do. So here we go. I've got x minus. What is the x coordinate of my center? So what's x minus -3? What is that? Okay, x plus 3 squared plus y minus. What is the y coordinate of the center? 4, yes, sitting right there staring us in the face. Squared is equal to the radius squared. What is my radius? 6. And when I square 6, I get... There you go. You've just come up with the center radius form for the circle described in example 1. So far, are there any questions? Okie dokie. Then graphing a circle. Now, again, you know me, you've known me for 14 weeks now. I am not super at drawing. So here's how you're going to sketch a circle that give you full credit for me on the test. First, the center's at -3, 4. This is not part of the graph, but I'm going to put it here just for reference. I'm going to put a small little dot there where the center is. And then since the radius is 6, here's what I'm going to do. I'm going to count 6 in each direction. So I'm going to go 6 up, 1, 2, 3, 4, 5, 6, make a fun little dot. I'm going to go 6 to the left, 1, 2, 3, 4, 5, 6, make a fun little dot. 6 down, 1, 2, 3, 4, 5, 6, make a fun little dot. And then 6 to the right, 1, 2, 3, 4, 5, 6. And you will get full credit on the test as long as you make your best effort to draw something that doesn't look like a square. Okay, so here we go. I can't draw and talk, so hang on. Oh, I got all happy because I thought it was going to be good, and then I got bad there on the right side. So, but that's okay. I think we all get the impression that that's a circle. Any questions about the circle or the drawing of the circle? You might say, Perkster, how did you make it this far in life without being able to draw a circle? And that's a great question, but can't answer it. All right, so if you would do the same thing, right next door is exercise 1. It's asking you the same thing. You're given the radius. Oh, I didn't do domain and range. Pardon me. I always forget something. So the domain, my x values, left and right. What's the furthest left? What's the lower bound of my domain? Yep, -9, indeed. And then what's the furthest to the right this goes? 3, perfect. There we go. And then the range, the furthest down this goes is -2, the furthest up this goes is 10, and there we go. There's my domain and range. So you'll do the same thing. You'll do the domain and the range on this first one, and then we've been doing that all semester. We don't need to do that for every one. So exercise 1, do the same thing. Equation, graph, domain and range, please. All right, let's see how you did on this first one. So my center radius form of the circle goes like this. I've got x minus, what's the x coordinate of the center? 6 squared plus y minus, what's the y coordinate of the center? So y minus -2 becomes y plus 2. And then the radius on this one is 4. 4 squared becomes 16. There's the equation. So far, so good. Now I'm just going to make a cute little dot here at the center, 6, -2. Remember, that dot is not part of the graph. It's just my reference point. Now I'm going to go 4 units up, 4 units left, 4 units down, 4 units to the right, and then oh, that is the circle of the year. So proud of myself on that one. Love it. Sometimes I Instagram my circles, so you can go to @theperkster and look for past semesters, parabolas and circles. And also when I'm proud of one, I post it because I'm a math geek and that's what we do. All right, so domain and range, here we go. The domain left and right. The furthest left, I hope you wrote, was 2. The furthest right is 10. There's your domain of the graph. And then the furthest down this goes is -6. The furthest up is 2. There's my range. Before we flip the page, we're going to do the same thing, but we're going to do it in reverse this time. So questions before we turn the page? All right, whoop, whoop, here we go. Next one. I'll help you with this example, and then you'll have yours to do. So this next one, I just do the reverse process because all we're doing here is getting to know our center radius form. What we're going to do is I've given you the equation, and you are going to identify the center and the radius and then do a quick sketch. So my center, what do you propose is the x coordinate of the center of this circle? Perfect, it's -3, because remember the standard form of a circle is x minus the x minus h squared. So since this is a +3, that means the x coordinate is -3. And what's the y coordinate of the center? Perfect, y minus 4, so the y coordinate is 4. Great job, there's my center. The radius is just the square root of the other side because 36 is the radius squared, so 6. There it is. So then -3 and then 4 and then 6 in each direction. So 6 right, 6 down, 6 left, and then 6 up. And I think this is actually, is this the same circle? Am I that not creative that it's the exact same circle? Good job, Perkster. Mental note, I've got to change that for next semester. Well, I guess I drew the same circle twice. I promise you the other two are not repeats of what you've already done. So exercise 2, identify the center, the radius, and graph that circle. All right, the center, what's the x coordinate of the center? -4 sounds great. What's the y coordinates? Perfect. Thank you for participating. -2. And then if this is equal to 4 on the other side, what is the radius of this circle equal to? 2. Great. Remember, this number over here is r squared. It's not just r, that number is r squared, so that means r is 2. So my center is at -4, -2. I'm just making a cute little dot right there, and then 2 up, 2 left, 2 down, 2 right, and there we go. Oh, that's pretty good. Maybe faster is better. Who knows? All right, one more. And then we just got a couple other style problems, and then we'll come to a good pausing point for the day and finish this when we come back next week. Exercise 3, find the center and radius of that circle and then graph it. What are the center coordinates of this circle right here? Yeah, there's no pluses or minuses here. So yeah, you're exactly right. It would be 0, 0. Perfection. That's why we're doing this example. I didn't really feel like we needed another one, but I just wanted to make sure we're clear on that. And then the radius of this one is equal to 8. So I'm just going to go 8 in each direction. So 8 up, 8 left, 8 down, 8 right, and faster's better. I just learned that. Oh, no, it's not. Not with the big circles. Okay, there we go. That's my circle. All right, so what we're going to do is we're going to try to finish up these other couple examples on this side of the page. That'll probably be the time that we have. What I will do, because I know Thanksgiving break's coming up and some of you might not want to have extra homework over the break, we will do the rest of this sheet in class on Monday next. So if you don't want to do anything, then great. If you just want to wait on your section 3.2 homework, but if you want to get ahead, I'll post I'll post the conclusion of this that I did in a previous semester. So if you want to watch it and finish this up so you can do the homework and get it all completed, that'll be your option. Okay, so either way, whatever's best for you, there's no penalty either way. All right, so example 3. We are going to find the center and the radius of this circle. Now, here's the challenge. This circle is not given to us in center radius form. This one's given to us in what's called standard form. When you take pre-calculus, you'll have to learn to differentiate between a circle in standard form, an ellipse in standard form, a hyperbola in standard form, because they're all related. They're all what's called conic sections. And if you don't know what that is, Google it. It's pretty interesting. Okay, but this you know is a circle, and I'm not going to try to trick you. There's no tricks. I'm not going to give you something on the test that's not a circle, but just for your edification, you know that this is a circle because the coefficient in front of the x squared and the y squared, that these are both positive and they're both equal. If they are, oh man, I always get them backwards because I haven't taught pre-calculus in a while. If they're both positive and they're not equal numbers, it's what's called an ellipse. And if one of them is negative, then it's a hyperbola. I believe that is, I got that straight. But you don't need to know that. I'm just giving you that for basic, fun weekend information. What we have to do on this equation is we have to do a process that we've done before in this class. We did this with parabolas. We are going to resurrect the idea of completing the square. Only difference this time is, if you remember when we did this with parabolas, the parabola was a function, it was in function notation, so we only had one side of the equation to work with, so we had to add something and then immediately subtract something. This time we've got a normal equation, so we're instead of adding and subtracting on the same side, we're going to add the same thing to both sides. It's the only difference in the process. So here you go. Same process we employed before. First thing I'm going to do is I'm going to group my x's and I'm going to group my y's. So here goes. I'm going to group my x's. So I'm going to put the x squared minus 6x in this parentheses. I'm going to leave a little space. Plus, I'm going to do y squared plus 10y. I'm going to leave a little space. And then that 25, that's right there, that number, I'm going to put it on the other side. So I've got equals negative 25. I'm going to pause so you can digest that. If I did too much in one step, please let me know. I don't want to lose anybody on the first step of completing the square. We okay so far? I grouped the x's, I grouped the y's, and then I put the number on the other side. Okay, so this is the completing the square step. Refresh my memory because this is something we've done before for parabolas. How do I get the number that I'm going to add right here for the x's? Does anyone remember the process? Okay, I'm going to look at this number right here, 6. What's half of 6? 3. And what's 3 squared? So I'm going to add 9 right here. And since I added 9 on the left side of the equation, I'm going to add 9 on the right side of the equation. Okay, so with that information, what do you think I'm going to add on the y's? Where'd you get the 25 from? What did you do? That is exactly right. Half of 10 is 5. 5 squared is 25. Anyone not seeing where the 9 and the 25 are coming from? And so since I added 25 on the left, I'm going to add 25 on the right. We're just about done with the problem. You've done all the hard work. Now, if you need to factor, if you need to go on your scrap paper and factor these, that's fine, but here's what we've got. What are the two factors of 9 that are going to add up to negative 6? That's going to be minus 3 and minus 3, so x minus 3 squared. That's why we completed the square, so that this would be a perfect square. And then what are the two factors of 25 that are going to add up to positive 10? They're going to be positive 10, so it's going to be positive 5 and positive 5, so y plus 5 squared. And then on the other side, when you grab your calculator and you add these numbers, negative 25 and 25, that's 0. They cancel each other out. That doesn't always happen. That's 0, and then I'm left with 9. So there's my equation. And alas, the question was asking, what's the center and the radius? Well, that's, once you got the equation, that's the easy part. The x coordinate of the center is 3. The y coordinate of the center is negative 5. And then my radius is the square root of 9, which is 3. Okie dokie. So with that information, here's our last problem for the day. I will have one other thing to mention in case you want to work ahead on this, and then we'll shut everything down. So please do exercise 4 as our last problem of the day. All right, just for time's sake, I'm sorry, I'm not meaning to make you feel rushed or anything. So first step, I'm going to group those x's and y's. I'm going to put that number on the other side. So I've got the x squared plus the 8x. I'm going to leave a little space. And then I've got plus the y squared minus 12y. I'm going to leave a little space. I'm going to take this 25. I'm going to put it on the other side. So that is equal to negative 25. Anybody caught off guard? We good so far? Okay, then what am I going to add when I complete the square? What am I going to add on the x's here? Half of 8 is 4. 4 squared is 16. So I add 16 on the left. I add 16 on the right. What am I going to add here to complete the square on the y's? Yep, half of 12 is 6. 6 squared is 36 on the left, and then 36 on the right. So now when I factor the things on the left, I get the two factors of 16 that add up to positive 8 are going to be x plus 4 and plus 4. And then the two factors of 36 that add up to negative 12 are going to be minus 6 and minus 6, so y minus 6 squared. And then negative 25 plus 16, that's negative 9. Negative 9 plus 36 is 27. Ooh, challenge, challenge. So the center, what's the center of this? Yeah, that's not the challenge. But here's another little reminder of something from the Wayback Machine. My radius is the square root of this side right here, which in this case is 27. The other examples have been perfect squares, but I wanted to make sure to include one of these. So the radius is the square root of 27. Which is great, but always remember we need to make sure our radicals are simplified. Does 27 have a factor that's a perfect square? Yep, it's 9 times 3. And so then I can take the square root of the 9 part. So my radius becomes the square root of 9, which is 3. That comes outside the radical because I took the square root. The other square root stays under the radical. And there we go. So make sure you simplify your radicals. One note before we shut it down. Just going to flip to page 3. On page 3, I mean, if you want to work ahead, page 3, exercise 5 is just another example of completing the square. Like I said, we will do that next time, but I will post a video from a previous semester. I just want to mention exercise 6 before you go. If you have a number in front of the x squared and the y squared, like we do here. Now, if it's a circle, it's going to be the same number, so it shouldn't cause you any trouble. But what your first step is going to be here before you complete the square is you want to make sure there's only a 1 in front of the x squared and y squared. So your first step on this problem is going to be to divide everything here by 3. And then it becomes just the same sort of problem as you had before.